The next question is 10th question B part. Consider JFET in a fixed bias mode. Derive expression for Z in Z0 and AV. If RG is equal to 1 mega ohm, small rd is equal to 50 kilo ohm, GM is equal to 2 millisiemens. Then calculate Zi, AV, Z0 and draw the circuit diagram, and RD is equal to 5.1 kilo ohm. So what is given in your problem? It is a fixed bias mode of your JFET. So first let us draw the diagram for your fixed bias mode. Okay, so here you have your gate, drain, source. Fixed bias in the input side you will be having an RG and your supply voltage VG, right? And you have in the output side you have RD plus connected to your plus VDD, and you have looking towards your input side the impedance is input impedance Zi, and looking towards your circuit from the output will be your output impedance, that is your Z0. Okay, so the same diagram I am going to replace it by your AC equivalent circuit. So AC equivalent circuit, what will happen? Your capacitors, coupling capacitors, input coupling capacitor, output coupling capacitor, and your VDD, that is your DC supply, will be short circuited, right? So here the same diagram, the equivalent circuit of your AC analysis, AC equivalent circuit will be given by the since it is a common source configuration, the source will be grounded. This will be your input side, that is your gate, and this is going to be your output side, that is your drain. Okay, and your FET will be replaced by your input side will be, you have your resistor RG, and your output side will be replaced by your current source and your internal drain resistance small rd, right? Your current source is gm into vgs. So you have the arrow mark towards down because your current flows from drain to source. That is why you have the arrow mark pointing downwards. Okay, and what is other circuit, you means other network element you have? Across the output you have your resistance rd, right? Rd. So if this is shorted, it will go to ground. So you have from the drain to the, since VDD is shorted, it will go to your ground. So it is reconfigured just like this. Looking towards the circuit from the input is your Zi, that is your input impedance. Looking towards from the output is your output impedance Z0. So we have to find out the formulas, right? That's why I'm explaining it in a glance. Okay, so what will be your input impedance? Looking towards your circuit from the input side, there is only one resistor RG, so your input impedance will be equal to RG. Output impedance will be looking towards from the output side, you will be having two resistance, that is your internal resistance RD parallel to capital RD. So that will give your output impedance, and your gain is equal to AV is equal to, what is your gain? Output voltage by input voltage, right? V0 divided by Vi. So what is your output voltage? You know that output voltage, which is equal to VDS, which is equal to voltage is equal to current into resistance. What is your output current? Output current is equal to, the current source is equal to GM into VGS. So GM into VGS, what is your resistance? Small rd parallel to capital RD. That's why you have got GM into VGS into small rd parallel to capital RD. You have a minus because the current is flowing from drain to source, which is in the opposite direction. So you have a minus here. Now for you know that AV is equal to V0 divided by Vi. Vi, you know that the input voltage is equal to VGS. So VGS get cancelled. Right, so you will be getting AV is equal to minus GM into small rd parallel to capital RD. By using these three equations, now you are going to solve the problem. So what is given in your problem? You have the data. Now what will be your input impedance? By formula, you know that input impedance is equal to capital RG, which is already given in your problem, 1 mega ohm. So your input impedance is equal to 1 mega ohm. What is your output impedance? Z0 is equal to small rd parallel to capital RD. Small rd is equal to 50 kilo ohm. Capital RD, which is given in the problem, is 5.1 kilo ohm. So what is your parallel connection? 50 into 5.1k divided by 50k plus 5.1k. So after solving, you will be getting it as 4.627 kilo ohm. The third one is your voltage gain. AV is equal to minus GM into this value already you have calculated here, right? RD parallel to RD. So you can, instead of this, you can substitute 4.627 kilo ohm. So after substitution, your GM is also given 2 millisiemens, 2 into 10 raised to minus 3, right? So you will be getting AV is equal to 9.254. So these are the three values which you have obtained from this fixed bias configuration.